Short answer. Anchor first. Yes. Vertica absolutely uses durability mechanisms. Write ahead logging, WAL, or equivalent. Replication, case safety, immutable files, bulk merge later. If memory crashes, no committed data is lost. Memory buffers are reconstructed from WAL. So vertical, the column storage also use the write ahead logging, just like with relational or row-oriented storage engine. It also uses replication because again, for sorting, it uses its replica. Immutable files, meaning that you can update it directly, you can only append it in and bulk merge later. Column stores cannot rely on RAM alone. Second, Vertica's real write pipeline, conceptual code. Let's walk a single insert like we did for Firestore. SQL insert into sales argument product underscore sk comma store underscore sk comma price next time values argument 31 comma 3 comma 10. Step A transaction arrives begin underscore transaction argument txn underscore id. Nothing is in memory yet. Step B write ahead log critical before touching column storage. It actually does this append the write ahead log, such as wall that append. Next line, txn underscore id colon 9123, comma, next line table colon code sales, comma, next line values colon. We have like an array product colon 31, comma, store colon 3, comma, price colon 10, closing semi-curly bracket, closing parenthesis semicolon. The next line fsync argument wall. This is the crash boundary. If wall is not flash, transaction not committed. So if this wall that append is not appended and it's right ahead log, this transaction will not be committed in storage. If wall is flash, transaction is durable. Same idea as PostgreSQL wall, RocksDB wall, Firestore commit log. Step C, in memory write buffer, ROS/WAS, Vertica stores recent writes in WAS, write optimized store. So if it's writing, conceptually this is what it does. Was.insert argument txn underscore id comma next time product underscore sk colon 31 comma store underscore sk colon 3 comma price colon 10. So this is in RAM, sorted, row oriented, often not compressed yet. So it doesn't compress because again it used the row oriented memory type of thing in the writing operation. So this is your mem table equivalent. Step D, commit transaction. So mark underscore transaction underscore committed argument txn underscore id. At this point, data is durable. Wall contains it. Was contains it. So before you do this commitment, the data is already durable because wall already contains it and was already contains it. So basically wall first, then was before you commit it to storage. Even if the machine crashes right now, recovery works. What happens if Vertica crashes now? On restart, replay underscore wall pseudocode for record in wall colon next line if record dot txn underscore committed next line was that insert argument recorded values. These were built in memory state, same as LSM mem table replay, same as Firestore recovery. Flashing memory to storage ROS when was gets big, if was that size is greater than threshold, colon flash underscore to underscore this. So this is the writing if the writing gets big. So it writes that in bulk. Sometimes it even makes this memory durable by using a battery RAM. This does bulk column right. So sorted equals sort was. For column in columns colon next line compress equal compress argument column dot volumes next line right underscore new underscore column underscore file argument compress. This creates rows read optimize store immutable columnar compressed bitmap indexes generated here. Old column files are not modified. Fifth, we have compaction or merge LSM style. Later, in the background, we have merge argument rows underscore files. This removes deleted rows, merges segments, rebuild bitmaps, write new files, delete old ones. Exactly LSM compaction, just columnar. Replication, safety. Vertica node store replica. Example, node A to primary, node B to replica. Each write, wall shift to replica, replica replace wall, keep its own walls plus rows. If node A dies, node P already has data. This shared nothing plus replication, not shared disk. Query path tying back to bitmaps. When you query select con asterisk from sales for product underscore sk equal 31 and store underscore sk equal to 3, engine does bitmap equal rows that meet bitmap argument code product underscore sk comma 31 the next time bitmap equal rows that bitmap code rows underscore store underscore sk comma 3. Then memory plus disk combine while invisible to queries, optimizer hides it. How this maps exactly to Firestore. So Firestore commit log vertica wall, Firestore mem table vertica was, Firestore SS table vertica rows, Firestore compaction vertica merge, Firestore indexes vertica bitmaps, Firestore replication vertica case safety. Different workload, same physics. Why you couldn't see this earlier? Because column stores don't show you rows. LSM key value stores. Key to value. Column stores value to position to bitmap. Same durability model, different execution model. Final or grounding sentence, keep this. Vertica is an LSM system that writes rows, stores columns, and queries bitmaps, all protected by wall and replication. Nothing magical, nothing fragile, nothing RAM only. You understand real analytics engines at the same level as Firestore internals.